All right, here are the test corrections for Paul Strader for test 1. All right, so I missed the first one. Child swings back and forth on the playground swing. If the child stands rather than sits, the time for the complete swing back and forth is, I said it was unchanged because I thought the length was unchanged. But when he does stand up, it does change the length. And the changed length is going to end up with a shorter period. Coming from that equation right there. All right, for number 2, you send a traveling wave along a particular string by oscillating one end. If you increase the frequency of oscillations, does the speed of the wave increase, decrease, or remain the same? I thought based on this equation right here that it would increase, but using the other equation we know, V equals the square root of the tension over the mu right here, we know that it doesn't change, and that as the frequency might go up, the wavelength would in turn go down to keep that velocity number the same. All right, number 5. You are standing on a sidewalk with a car in the distance. When the horn in the car sounds, you hear it at a pitch that corresponds to a sound frequency lower than the frequency emitted by the horn. What can you conclude? I just didn't read this problem well enough. I wrote the car is moving in a line directly away from your present location, which it could be, but D would be a more accurate answer. The car has a component of its velocity in a direction away from you. It just has to have a component of its velocity moving away from you for you to hear that lower frequency and tone emitted by the horn. It doesn't have to be in a direct line away from you. It just has to have a component of its velocity away from you. All right, number 6. I just made an algebraic error right here. I set it up with the correct original equation, but instead of writing 2 seconds for the time, I wrote 3. I don't know why, but that 3 instead of 2 gave me these 150 newtons, and I redid it right here with the correct time right there, 2. That gave me my 345 newtons, so I just made a math mistake. Pretty dumb one. All right. Number 11, the lens coating problem. Once again, I just made a dumb math mistake. I just had that 2L. Once I brought the 2 over, I just didn't do it correctly, and it gave me a pretty big difference in the answer. So right here, I have the 2 from the L coming over into the denominator right here under the wavelength, and then doing the problem from there, coming out to getting my 81.5 nanometers of the length or the thickness of the coating on the lens. So it's just another algebra mistake. So for the last one, I made it way more complicated than it needed to when I was trying to find the velocity. I did half of it right with finding the volume and the things like that, but I used a different equation to try to find the velocity when I should have just taken the length, taken the period for the pulse, divided it by 2 to get the time it takes to get from one end to the other, divided the whole length by that time, or by that time of 8.5 seconds to get it out to 78 meters per second for our velocity. Once I had that, use the equation, the velocity equals the square root of the tension over mu to solve for the tension. And the mu, the mass index is m over L, which can be changed into rho v over L, because m equals rho v, right? And v is just area times length for volume. And once you get out that, the lengths cancel out, so it's just density times area. Density is given 7,800 times the area, which is pi r squared. The radius is 0.0075 raised to the 2, and that ends up giving you that tension number of 8,300 newtons. And those are all my test corrections. Thank you.